Welcome to This Explainer. Today, we're embarking on a massive journey through time. When we hear the words artificial intelligence, it's incredibly easy to just picture gleaming server farms, advanced microchips, and sterile modern laboratories. But the truth of this technology is much more profound and honestly a lot more epic. Artificial intelligence isn't just some recent invention born in Silicon Valley. It's actually the ultimate culmination of thousands of years of human imagination. Long before we had the silicon, the wires, or the electricity to actually build them, intelligent machines lived vividly in the minds, the myths, and the dreams of our ancestors. So we're going to look at the sweeping story of how human curiosity planted the very earliest seeds for the technology that is fundamentally reshaping our world today.
To make sense of this massive historical arc, we're going to follow a clear roadmap. We'll start with ancient dreams and myths, move into the age of automata, explore the rules of logic, meet the pioneers of computing, and finally see how dreams become reality.
Let's kick things off with Part 1, Ancient Dreams and Myths and Humanity's Deep Fascination with Intelligent Machines. Let's explore where this fascination actually began, by tracing a direct line across millennia. Take the ancient Greek myth of Talos. According to the stories, Talos was a giant bronze robot forged to guard the island of Crete. This mythical machine could move automatically, detect enemies, and protect the shores entirely without human intervention. Now, fast forward to today. We have real automated defense systems, autonomous robots navigating warehouses, and intelligent digital assistants guarding our cyber networks. The ancient Greeks obviously didn't have the microchips or the complex code required to build Talos, but they fundamentally understood the concept of an artificial being that could process information and act autonomously. They dreamed of the exact same utility that we are engineering right now.
Which brings up a really fascinating thought experiment for us. Why do you think humans have always dreamed about intelligent machines? What advantages might they have imagined back then? Well, even in antiquity, people saw the stark limits of human endurance. We get tired, we make mistakes, our bodies break down, we need sleep. Imagining a tireless, fearless, automated worker or guardian wasn't just idle fantasy. It was a deep reflection of the human desire to transcend our own physical limitations. We wanted tools that could do what we simply could not.
Moving right along to Section 2, the Age of Automata and the Era of Early Mechanical Inventions.
This is the era where human engineering begins to slowly, finally catch up with human mythology, moving out of the realm of the gods and into the workshops of early inventors. To understand this, we really need to know what automata actually are. Basically, they are mechanical devices designed to move automatically. These were the very first physical, tangible attempts at automation. Because they lacked electricity entirely, early engineers had to rely on the forces of the natural world. They captured water pressure, the expansion of steam, heavy dropping weights, and intricate networks of brass gears to create movement. These magnificent, clunky devices were the prehistoric ancestors of today's robots.
Let's spotlight Hero of Alexandria for a second. He was a brilliant mind from antiquity who really pushed this engineering forward. He didn't just theorize, he built. Hero created automatic temple doors that would majestically open seemingly by themselves when a fire was lit on an altar. He built complex water-powered machines and mechanical puppets that performed automated moving plays, articulating in ways that made them appear almost alive. Think about how a modern vending machine works. You put in a coin, you press a button, and the machine automatically retrieves and drops your snack. Hero was using physical mechanics to achieve that exact same kind of automated, predictable response thousands of years ago.
Now put yourself in the shoes of someone living back then. If you lived thousands of years ago and saw heavy stone temple doors swinging open with absolutely no one touching them, or a mechanical bird suddenly flapping its wings in the courtyard, would you think it was magic or science? For the vast majority of the public, it was perceived as purely divine or magical. But in reality, it was pure, unadulterated engineering. It was humanity's very first awe-inspiring taste of automated physical power. When we zoom out and look at this massive timeline, we can truly appreciate the sheer scale of human discovery. We start deep in antiquity with the myth of Talos and Hero's physical automata, but as we move forward through time toward the 17th century with rigorous thinkers like Aristotle and Descartes, and into the 1800s with Charles Babbage, we see a critical shift. We begin to move away from just building the physical hardware of mechanical bodies, and we start attempting to map the software of the human mind.
Which brings us to Section 3, the rules of logic and the development of logical thinking.
Creating a machine that moves is one thing, but creating a machine that can think requires something entirely different. Before we could teach machines how to decide, we had to understand how we decide.
So what is logic? It's fundamentally a method of reasoning and problem-solving used to make decisions. Philosophers like Aristotle and later, mathematicians like René Descartes dedicated their entire lives to formalizing these systems of human thought. They realized that human reasoning wasn't just random intuition, it followed strict rules and patterns. And they hypothesized that if intelligence essentially follows a set of rules, then perhaps those rules could eventually be taught to a machine.
Logic works very much like a simple recipe, breaking down complex decision-making into digestible steps. Take an everyday human example. Step 1. Check the weather. Step 2. If it is raining. Step 3. Carry an umbrella. This core if-then conditional structure is the absolute unquestionable DNA of computer science today. Whether it's a person deciding to grab an umbrella to stay dry, or an advanced algorithm deciding which specific video to recommend to you next on your feed, both are fundamentally following a logical, step-by-step set of instructions to reach an optimized conclusion.
Which leads us directly to one of the most profound philosophical questions in this entire explainer. Can a machine truly think, or is it only following instructions? Even surrounded by the most staggering AI breakthroughs today, this specific question remains right at the fiery center of the debate. Are these massive systems actually intelligent, or are they just following billions of if-then rules at a speed so blindingly fast that it perfectly mimics human consciousness? The line between complex rule following and true intelligence remains incredibly blurry.
Let's dive into Section 4, Pioneers of Computing and Early Calculating Machines.
We have arrived at the Industrial Revolution. This is the crucial moment where the ancient ideas of logic and physical automation finally collide, as inventors try to reduce human effort in complex mathematics. Enter the man often known as the father of the computer, Charles Babbage. Babbage designed the analytical engine. And look, this wasn't just a simple abacus or adding machine, it was a true mechanical computer. Even though it was made of clinking brass and gears, Babbage's design featured elements perfectly identical to the architecture of modern machines. It had a memory to store numbers, a way to input instructions via punch cards, and a central processor to perform automatic calculations. It was a staggering leap forward for human engineering.
But Babbage didn't work alone. The true visionary mind of this era was his scientific partner, Ada Lovelace. Babbage simply saw a brilliant machine that could crunch heavy numbers. Lovelace saw something entirely different. She realized that if numbers could represent other things, like letters or musical notes, then a machine could process any symbol, not just math. This is exactly how modern apps work today, translating binary numbers into the videos you watch and the music you stream. Lovelace literally envisioned machines creating original music and solving vast, complex problems. Because she wrote the first algorithm intended to be processed by a machine, she is widely celebrated as the world's first computer programmer. Her vision entirely changed the trajectory of science.
Let's ground this history in our daily lives for a moment. What modern devices perform calculations automatically today, and how different are they really from early mechanical calculators? Think about the smartphone sitting right in your pocket. It is fundamentally a direct descendant of Babbage's brass gears and Lovelace's logical instructions. The difference isn't the core concept. The difference is merely speed, microscopic scale, and electricity. But the foundational idea, it's exactly the same.
And finally, Section 5, Dreams Become Reality, the foundation of modern AI.
By the late 1800s and early 1900s, the necessary catalysts for the modern era were fully in place, ready to weave these isolated historical threads into a single tapestry. Mathematics had vastly improved. Engineering allowed for microscopic, flawless precision. But crucially, electricity became common. This was the ultimate missing link. Electricity replaced the slow, physical movements of steam and water power with electrons moving at the literal speed of light. Suddenly, machines became exponentially more powerful. The separate threads of ancient mythology, Aristotelian logic, and mechanical automata fused together. The ancient dream of artificial intelligence finally had the physical tools required to become a tangible modern reality.
Consider this thought. Every great technology begins as an idea in someone's imagination. Artificial intelligence is the result of centuries of human curiosity and innovation. Think about that. It didn't just happen overnight. It wasn't the sudden invention of one single person in a modern lab. It is a baton of human curiosity that has been fiercely passed down through countless generations of ancient dreamers, philosophers, bold engineers, and brilliant mathematicians.
And that leaves us with this final, provocative question to carry with you. How does imagination help scientific progress? As we've seen on this journey today, science doesn't just invent out of nowhere. It builds what the human mind has already dared to dream. The myths of yesterday seamlessly become the technologies of today. And the bold things you are imagining right now, they just might be the science of tomorrow. Thank you so much for joining me for this explainer, and keep questioning the incredible world around you.